Hello students, today we are in lecture 4 of chapter 1 Electrostat. This is B.S. Pandey. Students, in last lecture 3 we have finished Coulomb's law, in which we have studied the general formula of electrostatic force, that is the Coulombian force, as F is equals to 1 by 4 pi epsilon naught Q1 Q2 over R square. Let me recall you, student. Q1 and Q2 are the 2 point charges. Q1 and Q2 are the 2 point charges are separated by a small distance R. It would be better, students, if you missed previous lecture, kindly go to the previous video. Here two charges are separated and the force we got here in magnitude as 1 over 4 pi epsilon naught Q1 Q2 over R square. Today we'll try to solve very simple question on the basis of this law, and then we'll study its vector form. So student, with a very simple question, in last class we have been discussed, in last lecture we have been discussed this law is inverse square law. Directly, if you are having the relation for the charge, that is charge is constant and the separation between these two charges becomes double, then how the force will change? It's very easy to give the answer. If the separation becomes double, the force will be 1/4 of initial value. Now, another question from this formula will be asked for the nature of force, whether the force is attractive or repulsive. We have been discussing property two like charges Q1 and Q2 repel each other, whereas dislike charges attract each other. Now the question is, if Q1 Q2, that is the product of two charges Q1 and Q2, is positive, then what will be the nature of force? And the second question, if product of Q1 Q2 is negative, here Q1 Q2 is positive greater than 0 and Q1 Q2 is negative, then what will be the nature of force? Here the force will be attractive or repulsive. Here the force will be attractive or repulsive. Here the force will be attractive or repulsive. You can pause video and find the answer. Let me tell you the answer. If product Q1 and Q2 is positive, then what are the probability? If Q1 Q2 is positive, either Q1 is positive, Q2 is positive, then the product will be positive, that is Q1 Q2 greater than 0. Another probability, if it is negative Q1 and Q2 is also negative, then the product will be positive, that is Q1 Q2 product Q1 Q2 will be positive. In this case, if both the charges are positive or negative, that is the similar charges, then force must be repulsive. So the answer should be repulsive. If product is positive Q1 Q2, then the force will be repulsive. Now the second one, if one charge, the second one we are discussing here, if Q1 is positive and Q2 is negative, then only we can have the product as negative, or the Q1 is negative and Q2 is positive, then only we can have negative. In both the cases, you can see both the charges are dislike charges. So what will be the answer? If both the dislike charges, the answer will be attractive. Why? Because Q1, Q2 is negative, that is less than 0. So the force will be attractive. And this way, you might face few more interesting questions. In this lecture 4, students, let me start now. Vector form. Vector form of Coulomb's law. Suppose we are having two charges in XY frame we are solving. You can solve in XYZ frame also. Okay, let me solve in XYZ frame. The two charges are placed over here as Q1 and Q2. This is the origin O. Coordinate of point 1 is, suppose, x1, y1 and z1. Coordinate of point 2 is x2, y2 and z2. If we find out the separation as a r between these two charges, here we suppose Q1 is positive and Q2 is negative. This is positive and this is negative. So we are finding here the force on Q1 due to Q2. As we know that if these two are dislike charges, so there will be force of attraction. Q1 will be attracted toward Q2 and Q2 towards Q1 as well. Force on Q1 will be in this direction because it is attractive force. It will try to move along Q2. This is the attractive force. The direction of this force will be towards Q2, and this direction can be considered as the unit vector r. The distance between this Q1 and Q2 in vector form we can write here r. Using triangle law, we can write this side O1, this point is considered as 1, this point is considered as 2. O1 plus 1, 2 will be equals O2. I hope you can recall the vector form. We have to find this r, that is 1, 2. Here 1, 2 is nothing but vector r. So this r can be written as, this is the r, can be written O2 minus O1. I have taught you to write directly the unit vector or vector from given coordinate. You can subtract the second one from first one, that is the second coordinate, and from first coordinate. So the r will be written as O2 is O2. 2 is x2, y2 and z2. So here the x2 minus x1 I cap, y2 minus y1 j cap and z2 Q2 minus Z1 K cap. You can also write here the R as delta X I cap delta Y J cap plus delta Z K cap. This is the R. Unit vector of R can be written as the vector R over mod of vector R. Here you can write R is nothing but the delta Xi delta Yj plus delta Zk over mod of, that is the magnitude of this vector, delta x square y square and delta z square. Simply you have to solve in this way. Now we have to find the magnitude and direction. I am erasing this one, students, kindly note down over your copy. We have to find the force on Q1 due to Q2. So in vector form, F can be written as the magnitude of force and direction of, that is the magnitude of force and direction of force. So the direction of force is along the R cap. Now we can write here the magnitude is nothing but the K Q1 Q2 by R square, that is the vector R mod square times unit vector R. This can be also written as the K Q1 Q2 over R square R cap. In NCERT both the form is written. You can use these two. Both are the important. K Q1 Q2 by R square R cap. Here R cap can be written as the vector R by mod of vector R. This is the mod of vector R. So you can write K Q1 Q2 by R square times, here the unit vector R can be written as the vector R over mod of vector R, and mod of vector R is itself what is R. So this can be written as K Q1 Q2 by R square into R, it is RQ times vector R. Remember students, if you are writing this vector form as F is equals to K Q1 Q2 by R square. Remember, if you are writing here the R square, then you have to put R cap. Otherwise, if you are writing vector K Q1 Q2 by R cube, then you have to put here vector R. Remember, both are the very important, and this is the very small differences in these two equations. Both are the same equation. This equation will help you to find the force if charges are placed anywhere, and this will help you to find the direction of force as well magnitude of force. We'll try to solve few questions on the basis of these two, and this formula will be very useful in competitive questions. Okay students, so let me solve few simple numerical questions, because numerical questions are important, because 14 to 20% of your 70 marks will be numerical question. It varies from 20 to 25%. 20 to 25%. Okay, now try to solve very simple question. Then after we'll move for the next law. Try to solve by yourself the very simple question I'm giving you, student. Here I'm not writing the question, so it will kill your time. Directly I'm giving you the question by the diagram. The two charges you are having, Q1 as plus 5 microcoulomb. Another charge, Q2 minus 5 microcoulomb, separated by 1 meter. This is the charge A and B. You have to find force on A due to B. You have to find the force in vector form as well as magnitude also. Okay, so try to solve this question. Let's find the answer. As these two charges are opposite in nature and we have to find the force on A, so try to find out the force on A, direction of force on A. This positive charge will move towards the B. It will move towards the B. That is, B will attract the charge A and it will move in this direction. Sometimes students fail to find the direction actually. On which charge you have to find the force, try to focus. You have to find the force on charge A and A will move towards B. So you have to put the arrow from A to B in this way. Now the force on A due to B, you can write here. If this is the x-axis, in question if axis are not given, then you can put axis by yourself. Now the magnitude will be K Q1 Q2 divided by R square and the direction will be I cap. Hope you understand. K, 9 times 10 to the power 9. Q1 Q2, it is 25 times 10 to the power, it is 10 power minus 6 and 10 power minus 6, 10 power minus 12 divided by R square. How much? It is 1 meter square in Newton. Now you can solve this question. It is 225 times 10 to the power minus 3 Newton. This is the direction I cap. This is the force on A due to B. You can write this force as 0.225 Newton also. Take your classwork and try to solve by yourself the very simple question. Here two charges are placed, 9 microcoulomb plus 9 microcoulomb and minus 3 microcoulomb separated by 2 meter. This is the x-axis. You have to find force on, this is charge A and B, force on A due to B. And second question, this is the charge minus 27 microcoulomb and the second charge minus 3 microcoulomb. This is the charge A and charge B. This is the direction Y. You have to find force on B due to A as well force on A due to B. The separation here is 1 meter for your simplicity. Now these two questions, students, try to solve by yourself. And now we'll study the next law. So the law of, or the principle of superposition, principle of superposition of forces. Later on we'll discuss the superposition principle and we'll utilize this principle in various physical quantity. Here we are talking about the superposition principle in case of force. Actually, superposition principle gives you idea to find the net force. Gives idea to find net force. Okay, to find net force on a charged particle. For example, suppose we are having a charged particle, say Q. The number of charges are placed as Q1, Q2, Q3, Qn. Okay, Qn. All are separated by very different distances at R1, R2, R3, and Rn. Here we have to find the force on Q. Okay, find net force. Okay, sorry, find net force on this charge Q. So the net force on this charge Q, I'm not giving here the nature of these charges. If you will have the nature of these charges, then you can write here the force will be in this direction, so and so. Okay, write Q minus, all the charges are minus, so this will move towards this one, move towards this one, and so on. Now in which direction this charge Q will move? Obviously the answer will be this charge will move towards the force, which will be the equivalent force, that is the net force. So how we'll find the net force? In the force is the vector quantity, so we can write the net force, that is the net force as the vector sum of all the forces, that is the individual forces acting on the charge Q due to the different charges F1 plus F2 and so on. It is the Fn. If we are finding here the force, net force on a charge by vector sum of the individual forces, this way is called superposition principle. Superposition principle gives the idea to find the net force as the vector sum of individual forces. Okay, so this is the superposition principle. Now using that superposition principle, we'll try to solve few questions. The very simple question I'm giving you over here. The first example, you are having a charge. This is the three charges are placed on the line over the x-axis as the Q, 2Q and 2Q. This is the minus, plus and plus, distance R and R. If you have to find the force at O, net force at O, okay, net force at O, then what will be the net force at O? Try to solve by yourself, because in gravitation you have been solved questions using superposition principle. I hope you can solve. Otherwise I'll solve this question. Actually I should give the key to solve this type of question. I should not solve, and this is first question, so I'm solving here. Okay, so the net force, first of all we'll try to draw the net force. Here this is the negative charge and this is the positive. There will be force of attraction between these two charges. Suppose it is F1. Okay, now this minus Q will be attracted towards plus 2Q. Suppose this is F2 on this charge O. The net force is vector sum. It is both the forces are in same direction along the x-axis, so you can write here the F1 plus F2 as F1 I cap plus F2 I cap. Now put the magnitude in direction. Here this charge Q1 and Q2, that is the minus Q, the K, Q1, Q, 2Q. So 2Q square over separation between these two charges R. So the R square I cap plus, for this charge and this charge, the force will be K, Q1 and Q2. K again 2Q square divided by, what will the separation? Now the total separation will be 2R, that is the 2R whole square. How much it is? 4R square I cap. So the net force you can calculate now using the vector method over here. Here the K 2K Q square by R square is common. So here 1 plus here 1 by 4 I cap. Net force is 2kq square by r square into 5 by 4 I cap Newton. This is the answer. You can simplify this answer also. Cancel out this 4 by 2. Now students, there are a number of questions you will be asked using this superposition principle. Take another question and you will solve this question by yourself. This is your classwork. Here 4 charges I am giving you. Q minus Q plus Q minus Q plus 2Q. The separation R. And this is the A, B, C and D. The first question, find force on A due net force on A. Net force you have to find. Okay. Second question, net force on C. Net force on C. Now try to solve by yourself. I don't think that you need my help to solve this question. This is a very simple question. Pause video and try to solve this question. Now I'm giving you the key. I'm not solving this question completely. I'm giving you the key. You have to find the net force on A. Okay, net force on A. This is the negative charge. This is the positive charge. So this charge will attract towards this one. So the first force between these two, the second force, that is the minus Q. This minus Q and minus Q. This minus Q will repel toward this. Remember students, if you are thinking that this will also repel in this direction, yes, of course it will repel. But these three charges, this one, are a static charge, that is the fixed charge. Okay, this is also fixed. We are finding the force. Okay, so it will repel, and the force, the second force I am writing here. This is the first force. This is the second force. Now between A and D, this is plus and this is minus. What will happen? It will attract. So there will be another force and it is the third force. Okay. So this is the net force on A. Now find by yourself magnitude and direction. Now the force on C. The force on C. So the force on C. Okay. Over this charge here, one by one, between A and C, there will be repulsion. But we have to find the force now on C, not on A. So it will move towards I cap, that is along the positive x-axis. So this is the first force. Now between B and C, this is positive and this is negative. So it will attract towards B. This is the second force. Now between C and D, this is minus and this is plus. So it will attract towards D. And this is the fourth force. I hope you are able to see. This is the fourth force. So this two force will sum up with I cap, and this will be subtracted from this two force with minus I cap, and the net force you can write. So in this way you can find the answer of this question. Now another type of question, student. Next type, you have to find the net force on A. Okay, this is plus Q minus Q and this is minus Q. The distance, suppose R, equilateral triangle. If it is equilateral triangle, the angle will be 60 degree. We have to find force F on A will be what? Okay, so try to solve this question. If you can solve, then pause the video and solve this question. Now let me solve. Here positive and this is negative. What will happen? It will attracted towards B. Suppose it is F1. It is positive and this is negative. What will happen? It will attracted towards C. Suppose it is F2. Now we are having force. It is F1 and it is F2, and the angle between these two forces is 60 degree. So we can write the net force as root under F1 square F2 square plus 2 F1 F2 cos 60 degree. I hope we remember this formula. F net will be simply try to find the value. F1 is force between these two, that is the K Q square, K Q1 Q2, it is the Q into Q square by separation it is R square. Remember, while writing the magnitude of this force, you don't require to take the nature of charge. Okay, this is plus and this is minus. Already you have been taken the nature of charge to represent the direction of force. So again you don't require to write the nature over here, that is plus into minus become minus. Okay, so you have taken already the nature of charge. This is plus and this is minus. That's why the force is attractive and this direction is taken from the nature of charge. So K Q square by R square, and F2 will be force between A and C. Again the magnitude of charge Q and Q. We are not taking here the nature because nature gives the direction of force and we have taken the direction of force. K Q square by R square. Now we'll write the net force here. Suppose this is as F, so of course this is also F. So the F net will be, here writing in the magnitude, we can write the direction also, the magnitude as F square plus F square plus 2F square cos 60 degree. It is how much? Half. So 3F square, that is F root 3. If you remember, two equal forces inclined at 30 degree give the root 3 times the magnitude of either force. Again you got the same result in Newton. Okay, by yourself you can solve this question as classwork. Now you have to find the net force on F net at B. What will be the answer? Okay, try to solve by yourself. Another question I'm giving you using this principle of superposition. If you're having the 4 charges placed at 4 vertices of a square, okay, the R, Q, Q, Q and Q, all the charges are negative and this is the positive. You have to find at net force at O. Find F net at O. Okay, you will solve by yourself. I am helping you here. The force between the 3 charges you have to find. Here the positive, negative, the direction will be in this direction. The force will be in this direction and the force will be in this direction. Of course, these 2 charges are same in magnitude and these 2 charges are same in magnitude. The force will be same in magnitude. So we are writing here the F. But this two charges are same in magnitude, but the separation is not same. Here the separation is r, but this separation will be root 2 times r. This is diagonal of square, root 2 times r. So the force will change. So we can write here F dash. Remember, this 2 force will give you the net force on the diagonal, because these two are identical force at 90 degree. So the net force will be at 45 degree, and the force will be in this direction. Suppose it is F naught. So the net force now will be FO plus F dash, nothing else. FO plus F dash. This is F dash, force due to these two charges, and F naught, this is the net force of these two forces. So we have to find F naught. So F naught is root 2 times F. Why root 2 times F? Because the two forces are perpendicular to each other, and the equivalent value of the two quantity mutually perpendicular to each other, we can write here the root 2 F, and F dash will calculate later on. So the root 2 times F. F is the force between any two charges. It is the k q square by r square. So the F net, you can write here the root 2 times k q square by r square plus F dash. It is the F dash, it is k q1 q2, that is the q square, by root 2 r whole square. It is root 2 kq square by r square plus kq square by 2 r square. Hope you are getting. Now you can solve this equation to find the net force. Okay, so this is easy. Even you can find the direction of this force also using the calculation of component method or using by vector method. Okay, so in this way you can solve this question. With this question we complete today's lecture, students. Thank you very much.